Today we're going to be talking about the volume of cylinders. Now, I'll provide you guys with these notes. You don't need to write them down. Just pay attention, okay? So first thing, what in the world is a cylinder? Well, it's anything that looks like this. The most classic example is a can. So it has circles for a bottom and a top, and a rectangle that wraps around it. Now, if I was to take one of these and cut it down to its different pieces, or if I printed one that I wanted to fold into a cylinder, it would look like this: two circles and a rectangle. Okay? Now, in order for us to find the volume of one of these, we've got to know a couple of things. So we're going to start by looking at some background knowledge dealing with circles. Now, for circles, I can have two different kinds of values. This blue line is called a radius, which is R, and it goes from middle to side. On the other hand, if I have a line that goes straight across, side to side, that's called a diameter. And these are side to side. People use a capital letter D to signify that. These two guys are related to each other by my diameter being twice my radius. And at the same time, my radius is just my diameter divided by 2. So either way, I'm either multiplying or dividing by 2 to shift back and forth in between them. In order to find the area of this, I use the following formula: pi r squared, where r is the radius. So if they give us a diameter, we have to convert it into a radius. Now, once we have that, we can actually find the volume of a cylinder very easily. Most of the time, you'll see people write it out like this: E times H. But wait a second, what is that H there? This guy. Well, that's how tall it is, the height. And on either one of these pictures, it's going to be this portion of the rectangle, telling me how tall this thing is. Always, we're going to refer to the circular part of this to be the bases, bottom and the top. Now, the reason is, we've never seen one laying on its side. It's always on the circular part. But what about that big letter B? Well, it's a simple explanation as well. This is the area of the base. That guy. My base is a circle. So my volume of a cylinder is actually pi r squared h. So notice I just plugged it in. Okay? So all I have to do is figure out how tall it is, what's its radius, plug them in, put them in the calculator. Okay, so let's go ahead and go through a couple of examples. I'm only going to do 4 examples. All right, so first problem. Here I'm going to first take a look at it, and I see that it has a line going from side to side. That's definitely a diameter, but I don't need a diameter. I need a radius. So I'm going to say radius is diameter over 2. Plug in my diameter, and we're going to reduce. I find a radius of 5. Now I look to see how tall this thing is. My height. Okay, now I have everything that I need. So let's go ahead and start plugging these guys in. Volume equals pi r squared h. I need my r. And I also need an h. Let's plug them in. Now, some people solve this and don't use the calculator. That's okay too. but we always want to double check our answers. So I'm going to say 5 times 5, pi times 25 times 6, 25 times 6. But that looks really weird. Because we can multiply or divide in any order we want to, I can write this as 150 pi. The reason why some mathematicians write it in this way is just simply because pi is a really long, crazy decimal. And so we don't want to truncate our answer and make it shorter than it needs to be. We want an exact answer. So some people leave it as pi. But if I needed something that was a little bit closer, such as on a test, I could just plug it into my calculator. 150 times seconds, and then this button to get my pi. Enter, and there is my volume. $471.24. I cut off my decimal here. This is 5 or greater, so I'm going to add 1. And back over here where I've written down everything, I noticed something. I don't have any units there. So what I'm going to do is I'm going to pull my units down. Whatever they are, I don't really care. I'm just copying them. And because this is a volume, it's cubed. So just to take a step back from that and give a little bit more of an explanation about that, if I have length with height, that's going to be inches to the power of an imaginary 1. If instead I have some kind of area, that's going to be inches to the power of 2. And these numbers apply no matter what unit of measurement. So meters, centimeters, millimeters, nanometers, feet, yards, miles, kilometers, same exact thing, okay? Volume, as you can probably guess, has a 3. So anytime I'm doing volume, I do 2 cubed, area squared, length, width, and height are just the regular measurements. All right, let's move on to another example now. So on this one, I see a line from the center to the side, that's a radius. I see from top to bottom, that's a height. Let's write out my equation. All right, let's go ahead and label everybody. All right, let's go ahead and plug these in. Now, I'm going to be really lazy, and I'm just going to switch over to my calculator and plug this one in. I'm not going to try and simplify this. Second, pi times 4 squared times 12. Enter, and I get this number. So my volume is equal to 603.19 something. I cut it here, truncated it here. This is 5 or bigger, so I added 1. So I have my number written down. Now I'm going to go ahead and look for my units. I'm going to bring them down. And I know that this is a volume, so it's going to have a cube. All right. Next one. Here's another example. So here I have center to side, radius, top to bottom, height. Let's write out my equation. Okay. Now I'm going to go ahead and identify my height as well as my radius. Let's fill them in. Okay, I'm going to use my calculator for this one as well. Second, pi times 11 squared times 1.5, enter. So my volume is 570.20. So I truncated here. I see this is bigger than 5. I add 1. That becomes 10. So I have to move it over here. That becomes a 2 and a 0. So now that I have my answer, I need to look for my units. I'm going to bring them on down. And as usual, because it's a volume, it's going to have a cube. All right, last example. Center to side, radius. Top to bottom, height. Let's write out my equation. Let me identify everybody. Okay, let's plug them in. All right, now I'm going to swing over to my calculator. Second pi times 4 squared times 24. My volume is 1,206.37. I'm going to go ahead and go back over here. I've written it down. Let's take a look at my units. Bring those guys down. And of course, because this is volume, inches cubed. All right. So, thanks so much for paying attention, and I will